Hello everyone, my name is Zhao from University of Electronic Science and Technology of China. Today, I will introduce a new composable and extensible Zhang with tilting rotors. Several modular Zhangs have appeared in the past few years, and they can be combined with each other to obtain different performance. At the beginning, we try to use a Zhang that can fly independently with fewer propellers as an individual module. In the process, we found that compared with using a full rotor Zhang, the combination of using a dual rotor Zhang will introduce a lot of interesting things. For example, different combination forms not only bring about changes in the load capacity, but also change the number of controllable degrees of freedom. Take the vertical combination category composed of two cells as an example. The cell itself is composed of carbon-breathing fibers. Two propellers are the power system of the cell. The servo can tilt the angle of propellers. A magnet is embedded inside the carbon-breathing structure. Cells are connected by magnetic force, and there is a magnetic interface on the carbon-breathing frame, through which cells can communicate. Different from the traditional quad-rotor module Zhang, the combination form of dual-rotor Zhang is diverse. Even two cells can be combined in a variety of ways. We classify all combinations into three categories and propose three control architectures. The first category shown in this figure is horizontal combination. All cells in this category will be aligned in a straight line, which has only 3 degrees of freedom controllable. The second category is a vertical combination. All cells in this category have parallel axes and will be aligned with at least 2 straight lines. This combination can achieve 4 degrees of freedom controllable. The third category is horizontal and vertical staggered combination. This combination can achieve 4 degrees of freedom flight. Let's ditch the formula for a more straightforward and intuitive explanation. The first category, regardless of the number of combined cells, can keep the Zhang hovering only when the pitch and roll angles are 0 degrees. When the condition is not met, no matter how the propeller is tilted, it will generate a force that makes the Zhang move. For the second category, when the Zhang is tilted at any pitch angle, we can make all the rotor planes parallel to the ground by tilting the rotor to keep the Zhang hovering. The third category is different from the first two due to the cross combination of independent cells. When the Zhang is tilted at any pitch angle or roll angle, the cell can offset the force of other cells by tilting the rotor. However, this method will increase the power consumption of the Zhang. The controller of first category adopts the traditional Zhang control structure, that is, double loop control. The output value of the position controller is used as the given value of the angle controller, and then the output value of the controller is distributed. The controller of the second category is changed in that the output of the x-axis position controller is directly transferred to the control distribution, while the given value of the pitch angle controller is given by the remote control. The third category Zhang can realize full degree of freedom control The value of the position controller and the angle controller are directly sent to the control distributor, and feed-forward calculation is added at the same time. Next, we will manually introduce the flight data of the second and third categories. In the second category, we have achieved 4 degrees of freedom controllability. When the pitch angle changes, we can still achieve stable position control and keep the drone hovering. We also tested the third category. The figure shows the flight conditions when the combined sails are 3 and 4. When the drone is hovering, the pitch angle and roll angle can still be controlled. Finally, I conclude my presentation. This study proposes a composable and extensible drone with tilting rotors with different acceleration capabilities under different combinations. All combined forms are divided into 3 categories, and 3 control frameworks are proposed to realize corresponding control. A decentralized module controller is proposed to allow cells to free cooperatively. We will explore the combinations of cells in 3D space and propose a unified control framework. Thank you for your attention.